So today we got a special guest in our class, Mr. Everett Alexander. So he will be with us for the whole time, I guess. So we got a rainy day today, and people are to come later, I guess. It's a little chilly outside. And I didn't expect this rain today, but yeah, I feel good about it. So I guess we're gonna start the new section today, and then we're gonna do the group jigsaw group activities like we did each week. Mm-hmm. Okay, so. Today we're going to discuss the quadratic equations. Okay, I'm sure some of you have heard about this before, or even learned a little bit about solving these equations in different ways. It turns out you can use 4 methods at least, according to our textbook, to solve a quadratic equation. So you can do it in different ways, but sometimes one way might be a little better than others. So it's up to your choice to use which way to do it. So we're going to introduce those methods one by one from the examples. Okay. So that'll be 1.2. 1.2. So chapter 1, section 2. Oh, 4 actually. I'm sorry. It's actually section 4. So let me just write down this section, and we're going to go through the methods. Okay. All right. So. Quadratic equations and applications. Okay. Can you see it? Mm-hmm. Okay. So what's a quadratic equation? A quadratic equation has degree 2, get x squared or something, in addition to the linear terms. So we're going to solve quadratic equations in different ways, as I said before. And we're going to do it by factoring first. Okay, so you can solve a quadratic equation by factoring, which means you can factor the quadratic term, the equation on one side, and then put each factor to zeros to solve the equation. Okay, so why don't we start from an example? That's example 1 on page 100. Okay, when you solve an equation of 2x squared plus 9x plus 7 equal to 3. So this is the equation we need to solve. We're going to do it by factoring. We discussed how to factor polynomials before, so we can definitely factor the quadratic terms. Okay. So the first step is to put all the terms on one side. So you're going to put 3 to the left. So if you subtract 3 on both sides, then you get a 4 on the left. So that becomes 2x squared plus 9x plus 4 equals to 0, then you will factor the left side. Okay, so first to put everything to one side and then use factor. Okay, so how do we factor the left side? How do you factor the? Yes. So we discussed the factoring before. There are different ways to do it, but for polynomial typically like this or quadratic terms, we can use factoring by grouping. Okay, so that's the method we discussed before. So the first step is to multiply the first number and the last number, remember? So we can multiply 2 by 4, so we got 8. And then the next step is to find the two numbers so that if you multiply them, you get 8. If you add them, you get 9. So those two numbers are 8 and 1. Okay, so you already figured out. Then we can use those two numbers to split the term in, the linear term into two. So we break the whole thing into 4 terms, like this. Okay. So you break up 9x into 8x and x.
Yeah,
and then you factor by grouping, right? So we can do, this. So so you can factor 2x from the first group, and that will give us x plus 4.
Yeah.
And then just keep the other the same, okay, unchanged. And then we got exactly. Then we get common factor of x plus 4 that can be factored from the whole thing. And so it becomes x plus 4 and 2x plus 1. Okay? So that's the factoring. We have done, the factoring. Then once we factor it, then we can solve it easily by setting each factor to 0, If we got the two numbers multiply, to 0, then one of them, at least one of them has to be 0, right? So what you do, you put x plus 4 equal to 0. That gives you one solution, and then you put 2x plus 1 equal to 0. That gives another solution. Okay, so I guess these things are easy to solve, we don't need the parentheses. So obviously we got x equal to -4 from the first equation. And to solve the second equation, you just put the 1 to the right side. It becomes negative. Okay, and then you divide by 2. So the solution from the second one is -½ So there are two solutions to this equation, -4 and -½ Okay, so this is how we solve equation by factoring. So you put all the things on one side and then you factor it. And then you set each factor to 0. Then you get all the solutions. Okay, so this is based on the things we learned before, and it's pretty good, but sometimes it doesn't work. Okay, so not all the problems will be solved by factoring. So we have some other methods to come, and the next method is called by square root. Extracting square root. So this is the second method. So we call it extracting square root. Okay. Extracting square root. What does it mean? It means, you can take the square root of an equation on both sides. Okay. and then you can use that to solve the equation, basically. And it works pretty good for some problems. So, for example, suppose we want to solve the equation with 3x squared plus 36. So we already got the x squared on one side and the a number on the right side. So I think it's pretty straight if you do it by taking the square root on both sides. But before you do that, you want to make the left side x squared instead of 3x squared. So what you do is just divide by 3 on both sides. Okay, then you can take a square root. So if you take a square root, obviously, what do you get? Okay, so you can get two solutions first. Okay, plus and minus square root of 12, right? So always remember, if we take square root on both sides, we get two solutions. Okay, because if you take a square of a number, it's always positive. So it comes with both positive and negative. So we use this method to solve the equation. Okay? And actually, if you try to use the first method to solve the equation, it will be pretty hard, because there are some radicals involved. So how do you factor it? It's a little tricky. So in this case, it'll be better to extract the square roots, right? Any questions about the example we just did? No? Okay, why don't we do another one? So using the extracting method. Okay, this time we got x plus 1 squared instead of x squared on the left and the 10 on the right side. Okay, so obviously we can use the extracting method to solve the equation if you take a square root on both sides, since we already have a square. So that's when you use the extracting square root. Okay, if it's already a square of an expression on the left and the number on the right, then you just take a square root on both sides directly and solve the equation. Okay, but remember, when you take a square root, you always got two solutions, both positive and negative. So in this case, if you take square root on the equation on both sides, you got x plus 1 on the left and both positive and negative square root 10 on the right. Does that make sense? Mm-hmm. Okay, so then you just subtract the 1 to get a solution. So there are two solutions again. Negative 1 plus square root 10 and negative 1 minus square root 10, but the people usually write both solutions in one expression like this. Okay, so you can see the quadratic equations usually give you two solutions most of the time. And this is the extracting square root. Okay, you take the square root. If the equation is already in the form of a square on the left and the number on the right, then you just take the square root and solve it easily. Again, we see some radicals in the solution. So if you try to factor it, there's another way to solve this equation. You can FOIL the left side and then try to, use the first method. You try to use the factoring method to solve it. It'll be not so easy because again there are some radicals involved. Okay, so in this case it would be much better to use extracting square root. Okay, so that's the second method. Any questions so far before we go to the next method? Okay, So this is the second method. And now let's talk about the third method, completing the square. Okay, completing the square. Okay, this is the method. A lot of people get confused. Okay, I don't know if you heard about this or before or not. It involves a little bit more skills, a little tricky to solve an equation by completing the square. You have to complete a square. So in the previous examples we had, we already got squares on the left. Okay, so then we can take the square root. But in some cases, in many cases, in many problems, the problem is not given in that form. And you have to rewrite the whole equation in like this, and then you solve it. So that's called completing the square. You have to complete the equation into a square root to solve it. Okay, so that makes a little more steps, a little more details to solve it. Okay, I guess we're going to start from an example in the book again. Page 102, example 3, and you will see how the method works. Okay, so page 102, example 3. When you solve the equation x squared plus 2x minus 6 equals 0, so when you solve this quadratic equation, and we have used, we have talk about factoring. If you try to factor this equation on the left, it turns out to be not so straight. Okay, and it doesn't work pretty easy. Not this one. Okay, so then we can try to use extracting square root. But the problem is not reading in the way that we can take the square root. Okay, it's not like this, and the goal is now to rewrite the whole equation in that form to solve it. So we need to convert the current form of the equation into a complete square. Okay, so how do you do it? So you have to do it in a few steps. The first step, the first step is to put the number on the right side. So we're going to add 6 on both sides. Okay. So this is different from the factoring method, where you need to put everything to one side. In this case, you need to put the number on one side and the other two terms on the left. And then we can try to complete the square on the left. Okay, complete the square on the left. And the way to do it is the following. Okay, I'm not going to talk about the formulas, the theories, but instead we just go through the examples, and then you can learn the skill. Okay, so we got x squared plus 2x equal to 6. And we want to, have a perfect square on the left side. Okay, so how do we start? How do we do it? Okay, Yeah, we're going to add some numbers, okay? We're going to add some numbers on both sides. And the number to add is, is 1. How do you get 1? You can divide the coefficient of the linear term, which is 2, by 2, okay? Whatever the number in here is, you just divide the number by 2, and then square it, and square it. Okay? So we got this. Remember to add on both sides. Okay, so obviously we got 1. If you divide by 2 and square it, you get 1. And then now, if you try to factor the left side, what do you get? What does the left side give you? If you try to factor it, huh? 2 and 1, pretty close. X plus 2 or 1. Yes, it's 1 actually. Okay, so it's 1. See, right? And this can be easily proved, or you can FOIL the left side. You will get the same thing as we had, right? So now we got a perfect square on the left. Now we can take the root.
How do you get that?
How do we? Any other questions? Huh?
Leave it like that.
Then you can solve it.
You're going to square it.
Yeah, you can take the square root. Yeah. So just like we did before, you take a square root and solve it. That's it. So we got both plus or minus square root 7. Now you subtract 1 both sides. Yeah, -1 plus square root 7. Okay, so you cannot combine -1 square root 7. No, they are not like terms. Okay, so that's the solution. So you can see the idea is to complete the square, to make it a square, to rewrite the whole equation into a square on one side, so that you can take the square root to solve it. Right? And how do you find the number to add on both sides? You can divide the number of the coefficient of the linear term by 2 and square it, and that will automatically gives you the complete square. Okay. So this is the first example. Why don't we do another one? Okay. Using the method of completing the square. Okay. So this is another example that can be solved by completing square. Okay. If you try to factor the left side again, it doesn't work. You cannot easily factor the left side. And so we have to, complete the square again. So far we only have those two methods. We have to rewrite the left side in complete square, okay, so that we can solve it. Okay, so before we do the other things, the very first thing to do is to make the coefficient of the leading term to 1, which is not in this case. So we got 2, right? 2x squared. So how do you make it 1? You just divide it by 2. easily, okay? So divide by 2 on both sides of the equation, and then we get x squared minus 2x plus half equal to 0. Remember, when you divide a number, you have to divide it by all the terms, right? So that gives x squared minus 2x plus half if we do it. And then we can start using completing square. Okay, so what is the first step now? Since we get this form, what do you do next?
Subtract.
Yeah, subtract 1/2, exactly. So then we get the negative half on the right and x squared minus 2x on the left. Then we have to add some numbers on both sides to complete square. So how do you figure out the number to add? Yeah, so you divide negative 2 by 2. And square it. Okay, so this is the number you add. Always divide the linear term, the coefficient of the linear term by 2 and square it. So again, we got negative 1 squared, which is 1. So we got x squared minus 2x plus 1 on the left and the negative half plus 1 on the right. Isn't it? Okay, so if we try to factor the left side, what do we get this time? Yeah, how do you factor the left? Now we should be able to factor the left side. X plus 1 or x minus 1. Yes, because we got the negative in here, right? So this automatically gives you a square on the left if you do that. Okay, so that's called the completing the square. On the right side, if you add negative half by 1, that gives you 1/2. Okay, so now we can take the root to solve the equation. So again, we got some radicals. So we got x minus 1 on the left and the plus or minus square root of half on the right. Again, always plus and minus. Okay. And the solution will be 1 plus minus square root of half if you add 1 on both sides. So this is the solution to the equation. So you can see you have to complete square to solve the equation. You cannot easily factor it again, right? So that's the third method. Okay. I guess I want to do one more example of completing square. Then we can do the group activities. Okay. So let's do example 5 on page 103. So this time the equation to solve is 3x squared minus 4x minus 5 equal to 0. Okay, if you try to factor the left side, it will not work out. If you try to factor the left side, it doesn't work. No. You always want to solve the equation by easy way, but it doesn't work in this case. So we have to do the completing square, right? So what would be the first step? Yeah, so you can do that, but you need to make that divide by 3 first, right? To make everything to make the first term 1. Okay, so when you divide, you have to divide each term by 3, so that will give us x squared minus 4 over 3x minus 5 over 3 equals to 0. Remember, you have to divide each term by 3 on the left. Okay, then you move the 5 over 3 on the right. Okay. So we get x squared minus 4 over 3x equal to 5 over 3, right? Now we are ready to complete the square on the left. Okay, so we need to add some number on both sides. So the number is coming from here, right? So we need to divide this number by 2 and square it, just like we did before, isn't it? Mm-hmm. Okay, but the difference is this time we got some fractions, so it makes a little tedious, but the method is still the same. Okay, so divide by 2. Negative 4 over 3 divided by 2. Okay, so whatever the number is, we just divide that by 2 and square it, right? It can be integer, it can be fractions, it can actually be radicals also. So everything works that way, okay? So we just add this thing, the same thing on the right. Okay. So if you divide negative 4 over 3 by 2, you're going to get negative 2/3, okay? 4 and 2, you cancel 2, you get 2. So that gives us negative 2 over 3 squared. Okay, so I know a lot of people don't like fractions, but sometimes you have to deal with it. So we got a few fractions to take care of. Now, if you square the negative 2 over 3, what do you get? If you square negative 2 over 3.
Negative 2/3.
Yeah, negative 2/3. You multiply it by each other, by itself. So what do you do? Just square 2 and square 3, right?
Yeah.
So that's 4 and 9, 4 over 9. Okay? Any questions about the fractions? Is it good so far? Mm-hmm. Okay, so there's an X there I forgot to put down. So now you can actually factor the left side, although it's fraction. And what it is always x minus 2 over 3 squared. Okay, so whatever the number you get in here, it comes to there. So you don't have to, do extra work to factor this. It's just that. Okay, automatically. Okay, you can prove it, or you can FOIL the left side, and you find actually it gives you the left side. Okay, so this is the left side, and then we can add the right side. So we got 5 over 3 and 4 over 9. So how do you add fractions?
Common denominator.
Yes, the least common denominator. So in this case it will be 9. So you can do multiply 5 and 3 by 3 to make the denominator 9, right? So that becomes 15 over 9, okay? And the 4 over 9.
Could be 19 over
Yeah.
9.
So that'd be 1909.
Over 9.
Remember, you cannot add fractions if they don't have the same denominator. Okay, so we got the same denominator, and then we just add the numerator. Okay, so we have a perfect square on the left side that we can take the square root. Okay, so let's just finish this problem, and then we can do the group activities. Okay, so any questions?
Yeah.
All right, so what do we have now is x minus 2 over 3 squared equal to 19 over 9. Okay, so just take the root now. We got x minus 2 over 3 equal to plus or minus 19 over 9. Again, you have to include both positive and negative. Okay, you can simplify the right side by taking the square root of 9. Okay, so you're going to get 3 in the denominator and square the 19 on the top. Okay. Then you just add 2 over 3 to get the solution. Okay, so we got two solutions. They are two-thirds plus or minus square root 19 over 3. Okay. So sometimes people would put everything, in one fraction like this. So you put the 2 plus or minus square root 19 on the top. We got same denominator 3, right? Okay, so this is another way to write it. So another form. Any question about this problem? All right, so I guess we're ready for the group activity now. Jigsaw group, we got the little time left. So let's see, any questions before we do that? I guess we're going to do 4 groups again. So you might want to join the first group, David. So U4 will be the first group, and the U4 will be the second group. I guess, yeah. So U3 will be the fourth group, and the U3 will be the third group. So each group we will solve a different problem. Okay, in different ways. Okay, so let me give you some problems to solve. All right. Okay. Group 1, you're going to do x squared minus 10x plus 9 equal to 0.
I don't think you got 3 groups.
3 groups? Okay, we can we can do 3 groups. So can you go back to join them? I'm sorry. Yeah. So U3 will be the first group. Okay. So why don't you come to join them? Okay, so the other groups are the same. So group 1, solve this equation. Group 2, okay, x plus 2 squared equal to 14. You're in 1, 2, 3, 4. So we got the 4 groups again. Okay, that's good. So each group has 3 people. Okay, so yeah, so that's all right. So we still got the 4 groups. All right, so now the third group, we will solve the equation, of this. And the fourth group, we will do x squared minus 2x minus 3. Okay. You might find different ways to solve the same problems, but I want you to do it in the way, yeah. So I think, the first problem can be solved by factoring. So why don't you just factor it to solve it? And the second group will be just extracting square, right? So that's extracting square. Square root. Square root. And third and fourth will be completing square. Okay.
What group we in?
You are still in group number 4, yeah.
Okay.
Completing square. Okay. So.
They going like this. 1, 2, 3, 4.
Right. So this is group 1. That's group 2, group 3, and group 4. So you have to find those. Do those problems using different ways, but in problem 3 and 4 you're going to do complete square, and the group 1 just do it by factoring, group 2 by extracting square root. Okay, so I'll give you a little time to discuss the problem, to work it out, and then and we'll see how it works. And then you're going to explain to other groups how you do it. So you can look at your notes and do the same thing. We got similar problems in examples. You just follow the same steps to do the problems. So in the first problem, you need to factor the left side. Okay. And the second problem, you just take the square root on both sides. You got the answer? Right, yeah. You're probably right, yeah. So you can factor that by x minus 1, x minus 9, yeah. So that's the answer for problem 1. Yeah. Yeah, just look at the examples we did in extracting square root and do the same thing. Yeah, just do it step by step. It's exactly the same.
Yes, sir.
And 3 and 4 you have to do a little more work, but it will be pretty straight. Let's see. Okay, that's problem 4, isn't it? So okay, almost right. First, so you can this will be minus instead of plus, right?
Oh yeah, minus.
And that's you take square root of 4, you get 2. Yeah.
Yeah, I got
So
it.
yeah, so you can end up with 2 integers. If you
I do got 2 numbers.
yeah. So then
It'd be cool.
yes.
Oh, you go by this one?
Yeah, this one will be minus, and then you take the root of 4, what do you get?
2.
2. So it's not square root 2, isn't it? And then you can find out the two solutions, right? So if you use the plus, 1 plus 2 and 1 minus 2, those are the two solutions, right?
Yeah.
So what are the two numbers? If you figure out the two numbers again, what are they? 1 plus 2? What is 1 plus 2?
3.
And 1 minus 2?
1 minus 2 negative 1.
I mean,
Negative
1 minus 2?
Yeah.
Negative 1.
Negative 1. So those are the two solutions, right?
Right here. We get that wrong.
That one is just from the, that number divided by 2.
And where you get different from right here?
That's the number in here
Divided by 2.
divided by 2, the same.
Okay.
Yeah. It's always the same kind of thing.
Okay.
I've got to know like this.
So, let's see. X plus 2 equal to plus 2, yes, pretty good. And yes, so that's the solution. So, yeah. You might want to discuss with your group who are not members and make sure everybody understand. Okay. Darren, did you try the problem?
Yeah.
Okay, did you get the answer? Okay, let's see. Okay. Do you want to discuss with them? Or is that the... Okay, yeah. I think you're almost right. This is the problem, right? It might be 14 instead of 10, right? If you take the root. Yeah, that's square root of 14. Oh, okay. Yeah, I know that. So, let's see. So I guess you got the right answer. So you guys can discuss the problem, and make sure everybody knows how to do it.
Yeah, Coach, you can explain it.
Yeah, so you can join him and to so.
He gonna send me to somewhere over here. He gonna send you to a different.
Yeah, so okay, so everybody has to know how to do it, and you can explain to other groups. Okay, so let's see. Did anybody figure out the?
I know what the answer is.
Number 3?
Yeah.
Yeah. Did you try the method we did?
4 and negative 8.
Do it from the side.
Yeah, I think you're probably right. But did you do it in the same way as we did in completing square? Yeah. Okay. So you want to discuss with your group members to make sure they know how to do it? Did you figure it out? Okay, so 4, you see? So what is 4? 4 over 2.
Mr. Google,
Yeah.
where were we saying it did? 452?
450.
Your office?
Oh yeah, 254.
254.
Yeah, 254.
You going out to class?
Yes, I will. Yes. Yeah, I will come back to the office after. Yeah. Did you figure it out? Yeah. Did you figure it out? Okay, so I guess we're going to continue the group activity next time. You're going to explain to other groups how you do the problems. Okay. Any questions? No. All right. So I guess we did the good one today. So I'll see you on Wednesday. So we're going to have a quiz. We're going to put the quiz on Wednesday instead of Friday because the.
We're going to be on this?
Yes, definitely. Because there's no class on Friday, so we're going to do it on Wednesday.